solid, liquid, and gases, but we like went higher level, so we just did pure water today.
Sorry, what do you say you did today?
We did pure water today.
Pure water. No, that's purification of water, right?
Yes, sir.
Mm. Can you tell me more about it?
If the particles they're not the same, then it's impure. So like its boiling point won't be 100 degrees and its freezing point won't be 0 degrees. But if the particles are the same, then it's pure.
Mm. That's good. That's impressive. That's impressive. All right. Okay. So now, I'm thinking perhaps we look at water purification, or we discuss um we do experiment about crystallization, but let's see how it goes. Trying to share my screen so you will be able to see clearly what we're doing. Now, in that water purification, you said you learn about those samples that are pure and those that are not pure. Okay, so this will teach us, and this is going to teach us about, you know, the indications, how pure, how, very clean those substances are. But meanwhile, so sorry, please, permit me to use my pointer so that you see how I navigate. All right. Now you have the instruction on the screen. You have the instruction on the screen. I want you to read this loud. Can you read the instruction? And we're going to do that. Can you read that?
Use the universal indicator paper to measure and record the pH of the water sample.
Okay. So we're going to use the universal indicator paper to measure and record the pH of the water sample. Now this is, here we have pH, and pH is a function of different colors. Okay, so when the pH is 14, so we see what the color is going to look like, and when it is 0, we have what the color and other numbers that shows. So they has to use the universal indicator paper to measure and record the pH of water sample. So this is the universal indicator paper. Okay, we insert it in the first sample. So now looking at this, what do you think? You have to compare it with one of these color, then that will make
I
you
think
know
it's
any
6.
color. 6. Okay, let's see. So which means, what is the pH of sample 1? That's going to be what?
6.
6. Good. So we can record the pH for sample 1 to be 6. Okay, 6. Then we do for sample 2. I'm going to insert it in sample 2, the indicator. Then, so I want you to observe clearly again and tell me what its pH.
13.
13. Okay. All right. Did I say 13 for water sample 2? 13. All right. So we do similar thing for water sample 3. We insert the universal indicator paper to measure that. Then we take it to
1.
the pH meter. Sorry, you said what?
I think it's 1.
1. Okay. So we'll record that too to be 1. All right. So then we have the next instruction. So I want you to read this out louder.
Accurately weigh an empty evaporating basin and record to 2 decimal places.
Can you read that again, please?
Accurately weigh an empty evaporating basin and record to 2 decimal places.
So now this is an empty evaporating basin. You remember we learned how to name, how to identify chemical apparatus, isn't it?
Yes, sir.
Good. Good. So what is the name of this?
Uh,
Evaporating what?
basin.
Good.
Evaporated basin.
How about these ones?
Uh,
What's their name?
beakers.
Very good. How about this?
I can't remember the scientific name, but is it like a scale?
Yeah, that's a balance. That's a balance. Or like a scale, you are right. Okay. How about this one on the table? What are they?
Conical flask.
Yeah, conical flask is right. Okay, so now we want to weigh this. So what do you see on the screen there? What's the weight? What's the weight? Hello, can you hear me? Hello, Adedayo, are you there? Are you there, Adedayo? Can you hear me? Can you hear me?
39.25.
39.25. Okay, that is the weight of the, empty evaporating basin. So empty mass of empty evaporating basin, we're gonna put that here. 39 point, what do you call it? Did you say 39.25?
Yes, sir.
Sharp. Okay, so we get its weight there. Now we have the instruction. Can you read the third instruction in there?
Pour 10 centimeters cubed of water sample into the evaporating basin.
So we asked to pour 10 centimeter cube of water sample 1 into the evaporating basin. Okay, so we're doing that now. We want to pour this here. Okay, we just poured. Did you notice the new weights after we poured that?
Yes,
After
sir.
we poured the sample. So that was 50, 0.22. Now read the fourth instruction in there.
Heat the evaporating basin on a water bath until the solids start to form and the the majority of water has evaporated.
Good. So they want us to heat the evaporating basin on a water bath. This is a water bath here. Okay. We have the Bunsen burner. There is a wire gauge and the tripod. I hope you still remember we did this. How to identify laboratory equipment. What is the name
That's
of
a
this?
Bunsen burner.
Good. How about this?
Goes
Good. How about this?
tripod.
As a tripod. Okay. So now they want us to heat the evaporating basin on the water bath. Okay. Until the solid starts to form and the majority of the water has evaporated. So going to heating that now and solid are forming. Solids are forming. Can you see the solid form there? Can you see the solid form there?
Yes, sir.
Good. So it took us to the next procedure, which is that. Can you read the fifth procedure?
Weigh the cooled evaporating basin and get calculate the mass of the solids that will dissolve in the water.
Good. So they want us to weigh this again. Weighing that again. So can you see what that is? Weigh the cool evaporating basin again and calculate the mass of the solid that were dissolved in the water. So what do we have in there? 40.22. Okay. So now tell me, how do you calculate the mass of the solids that were dissolved in the water? Can you tell
Um,
me?
do you cube it?
Sorry?
Do you like times it to the power of three with cube it?
No. Okay, let me help you this way. We calculated the mass of the empty basin. You remembered? You can write it somewhere. The mass of the empty basin, okay, that is the mass of the empty evaporating basin was 39.25, and the mass of the basin, are you writing it? the mass of
Yes,
the
sir.
basin and water, not empty
39.
basin now. When you now pour water there, mass of the basin and that of the water, we measure that to be 50.22. All right. Then the third thing there, the third value we got was 40.22. That is when we evaporated the water. Okay. Then the solid, we are asked to calculate, we have solid left, then some water have evaporated. Okay. So what we have here now, he said, weigh the cold evaporating basin again and calculate the mass of solid that were dissolved. So when we weigh again, we have 40.22. So can you now work it out and tell me what will be the mass of the solid that were dissolved in the water? So
So
I will
I
give you
still,
1 minute to
so I
calculate.
still
Sorry.
don't get it. Like, I don't really
Okay.
understand.
All right. I have to explain again. I have to explain again. Now, we measured, we measured the weight, okay, of the empty evaporating basin. We measured the weight of the empty evaporating basin and we got 39.25 for the empty evaporating basin. Then thereafter, we pour water in sample 1 into the evaporating basin. Therefore, it makes the weight of the basin to increase to 50.22. That is basin plus water. Then after we evaporated the water in the basin, okay, and we got this solid sample, right? So now we have the basin and the solid sample, and the weights of the basin and the solid sample now is 40.22. That is the water as sacrifice now. We now have the basin plus the solid sample, okay, that we are dissolving water. The weight of the basin together with the solid sample is 40.22. Now, we are now asked to calculate the mass of the dissolved solid, okay? The
I think
mass
I
of the
get it
solid
now,
that
sir.
rather, sorry,
I think I get it now, sir.
very good. So what will be the mass of the solid that were dissolved in the water? Can you tell me?
I'm looking at it now, sir.
You are
Is
working
it
it out,
zero?
right?
Is it 0.97?
0.97. Did you say 0.97?
Yes, sir.
Okay. Can you tell me how you work that out?
40.22 take away 39.25.
30, 39.25, 0.97 is brilliant. Very good. Very good. 0.97. So it means she thinks very well. So mass of solid dissolving 10 mil. So that would be for sample one, 0.97. Okay, if that is needed. All right. So now, can you read the instruction here
Which
and
of
answer?
the following was the mass of the solids dissolved in the water?
Good. So you have four options in there. So what is the correct option? What is the correct answer?
0.97.
0.97. So let's see that. Good. Good. Said correct. Since there was some solid in the liquid, it couldn't have been pure. Okay. So sample one is not pure. Why? Because some solid are present. And what is this mass of the solid present there? 0.97. Impressive. Impressive. You've done impressively well. So now here, you will write this down in your booklet, but you have to arrange it. You have to write them in, you have to look at everything first. Then you write them, you rearrange them. It has been scattered here. Then you have to rearrange in a regular manner the exact procedure we follow. So to do that now, all right?
Yes, sir. So I'm done.
All right, good. Sorry. A minute, please. All right. Now, can you tell me what you put for number one?
Number 5.
5 for 1. Okay, let's see. Good. That is accepted. And what you put for number 2?
2.
Sorry, I can't hear.
I put 3. Number 3.
You put 3 for 2. Okay, that's impressive. That is also correct. And why do you put for number 3?
5.
5 for 3. Those are very, very impressive. They are right. They are correct. Okay. So you've been congratulated that for completing the practical. Okay. So that is impressively okay. All right. So completed our part of the concept. So let's go back to class. Let's do this work. I'm going to do the first one. Sorry, the first one has been done. And I will do the second one and also the third one. Then you will do the remaining. So what do we have here? Instruction says, what do this formula mean? Complete the table below. Now, this is the formula. They want you to interpret it. How do you pronounce it? You say 2 hydrogen atoms, right? That is how you pronounce that. Then for the second one, so you say Na is sodium, right? So you say 1 sodium atom and 1 chlorine atom. Is that clear?
Yes, sir.
Good. Then for this one, Al is aluminum. So the formula contains 2 aluminum atoms. Excuse me, please. And 3 oxygen atoms. Sorry, my pen failed here. Okay, so I would like you to do the remaining now. But meanwhile, you have to write this and then you complete. Excuse me. Do you understand what to do?
Yes,
All right. So start.
So for the second to last one, I'm not sure, but I'm having a go.
The second to the last one.
Yes, I'm not sure, but I'm going to try.
Okay. Before you try, in mathematics, when something is written like this, what does it mean? That would be the
Um,
answer.
what I do is I do the
You're glitching.
uh what I do is that I do the brackets first, then I do the outside as in bit mass, but I don't really know what it is or like what it's called.
Brackets mean what in mathematics? What does
Hi.
bracket mean? Yeah. So that's what's going to happen there. But you're not time seen to be obvious. Anyhow, do it. Do it the way you get. Do it. Let me know when you are done.
Yes, sir. Yeah, I really don't know the last one, but I've done everything else.
All right. Okay. So, what do you pull for this?
One calcium atom and three carbonate atoms.
Hmm, that's not correct. There is carbon there. There is oxygen. So it is better of one calcium atom, one carbon atom, and three oxygen atoms. Do you understand that?
Yes, sir.
So, and I know you might have made similar mistakes or this, and this. You're going to write them in pieces, in atoms. Each of the atoms, you break them down. Okay. So meanwhile, let me give you as an assignment to to correct that. You will correct that as an assignment, okay? So that when we meet in our next lesson, by God's grace, next week, so we're going to do justice to that, the correction. Is that clear? Is that clear? Can you hear me?
Yes, sir.
Okay. So let's stop here, redo it. so that when we meet next week, we're gonna continue from there. Do you have any question you wanna ask?
No, sir.
All right. So in the absence of question, do have a lovely day ahead. Bye.
Bye, sir.